So this is a problem with friction, same as the first tension problem we did. So the concept's kind of the same, but there's an added trick in that now there is friction. And friction is pulling back with 100 newtons. Now, this is going to get even harder later because I'm going to teach you how to calculate the friction based on the coefficient of friction and the mass. And so you're going to have to do multiple steps. But for now, I'm just going to tell you the force. And there's only one other force you have to calculate. What's the other force we have to calculate, Yasmin? Yes, you're right. Gravity. Good. Do you know how much it is? What's the acceleration of gravity? We're making it 10. So how would you calculate the force of gravity on 25 kilos? This is where I find out that nobody knows what I've been talking about. Force of gravity equals the mass times g. Okay. So we would do 9.8, but because we're doing this in kind of a simple way, we're going to round that to 10. So 25 times 10. Nanato, what's the force of gravity on this block? He's squinting. Are you? Pardon me? Do you have trouble seeing the board? Is it hard for you to see this? Yeah, it's okay? Okay.
I can tell you.
Yeah, I know you can. Sahan, what is the force of gravity on this block? Do you know the number? I don't want to say it. Yeah, that's right. That's right. 250. She knows all the math, but she doesn't want to say it. This, 25 times 10, 250 newtons pulling down. So, if we open this up, we have a tug of war, 2 blocks. We have 25, and we have 10 on the other side. And we have 250 newtons pulling to the right, and we have 100 newtons pulling to the left. There's something we should probably do at this point. What would you do? We have to define something. Peria? Good, good. Which way would you make positive?
Left. Yeah, right.
Who would, there's no right answer about this. How many of you put your hand up if you would make left positive?
No.
Interesting. And who would make right positive?
Yeah. Oh,
Okay.
because then you get a
You people that said left positive, are you left-handed?
No,
Are you left-handed? No. Why did you pick positive this way? Just
I don't like left. I
you
like right.
you like left?
No, I don't like left. I like right.
But you don't like left. But you made right negative. Do you
No,
like
I made
negative?
right positive.
Oh, I thought you were saying. Okay, so let's say this is positive, this is negative. I usually make the bigger one positive because then you come out with positive answers. It's kind of nice. What's the net force here?
150.
150.
Good. Jimmy, how do I get the net force? Good. So if you're mathematical, if you're thinking mathematically, you're going to say the net force is always the sum of all forces. But the 100 is negative 100, right? So you're just adding them together. If you're a real world thinker, you're going to be like, nah, I don't need any of that. This one wins, it's bigger, and it wins by 150. So you just subtract the two, and that's 150 that way. Either way is fine. But you do, if you're mathy, you do want to remember this is negative 100. So your net force is 150. After that, it's exactly the same, right? F net
35.
equals what? What's the formula? It's up there.
F net equals MA.
F net equals MA. Thank you, Sam. If this equals MA, then what does A equal?
F divided by M.
Good. Divide both sides by M. So F net
Don't show it.
over M over the mass is going to equal A. But which mass?
35.
Total.
The total mass, right? Good. So you're going to go 150 over, what's my total? 35? And you should get like 74 point something. 4 point what?
3.
4.3?
Yes. Let's go, class.
How many people got 4.3? Good. Excellent. Excellent. So that's a basic tension problem with friction. Now, oh, sorry, Perry, you have a question.
I think you might say it, so.
Okay, no, go ahead.
I was asking, what is this asking for, what the tension is?
Oh, mind melt. I was just going to say that. Okay, next thing. F net equals MA. F net is sum of all forces. If objects track together, they have the same acceleration. Remember those things. Now, from that situation, find Ft.
That's
Not theoretically impossible. You're all, I see a lot of blank looks out there. Know how to find the acceleration. How do we find the tension force?
okay.
Adam's trying, I'm going for the win. How did we do that?
No.
Okay,
In a real world, would there be 2 tensions on that rope? Because there's a pulley on it.
in the real world there is infinite tensions on that rope. Well, maybe not infinite, but it comes down to the number of particles in the rope, which is a lot.
Yeah, true, but like, does a pulley affect the rope in any way whatsoever?
Yes.
Apart from friction?
There is friction, in the real world there's friction in the pulley, and generally this rope stretches a bit more over the pulley, so if the rope's going to break, it's probably going to break either here or there.
I see.
But we don't care about that in Physics 11. Don't worry about that. What's the first thing you're going to do if you want to find tension? Come late to class, that's what you do. Then you find tension.
You gotta know,
Very good. Asia, fire today. So, remember, this is a strategy. You have the whole system, right? And we use the net force on the whole system to find the acceleration. What do we know about the acceleration? Good, Yazzie, good. It's the same for all the objects. So if I know the acceleration on this, I can calculate its net force, right? And if I know its net force and I know that friction is 100 this way, I should be able to calculate the tension force because the net force on this block has to be the sum of this force and this force. Does that make sense?
wait, hold on, can you re-explain that?
Yes. So we use the whole system to find acceleration down here, right? You found the net force. You added these two forces, these two big ones. Why, when we did the whole system, why did we not have to add in the tension?
Because it wasn't affected.
Isn't that part of the net force? The net force is all the forces together. Declan? Good. This tension and this tension are gonna be acting in opposite directions. So you could add them in, but they add to 0, because one's positive and one's negative. So as far as the whole system is concerned, it's really just this gravity and this friction doing a tug of war. But if we break that down and look at just one mass, well, now this mass has a tension pulling this way, but this tension is over there. That's not part of this block, right? So now we can find this tension, because this tension and this friction added together is the net force on this block.
Oh.
So you think of the whole system,
Now you think of.
you get the acceleration. The acceleration is what links the blocks together. Does that make sense? It's kind of real world thinking. They're going to move together, so they're all going to accelerate the same. But the net forces are not the same. So you chop it in half. Go like this. And you go, okay, now I'm going to think about just one block. And I'm going to get the net force on that block. And then I'm going to use this fact to find the tension. And I can do it on the other block as well to check. Right? So let's do that. I'm going to draw this 10 kilos here. What are the forces acting on the 10?
Friction and tension.
So you've got friction pulling backwards. How much was it?
100 newtons.
Applied force going forward. Or I don't even, is that applied force? No, force of tension.
Good. You got tension going forward. We don't know how much it is. Do you think it's bigger than 100 or less?
Bigger.
Which way is this going to accelerate?
That way.
That way. So which one has to be bigger?
F.
This one has to be bigger, right? But we don't know how much bigger. Yeah. But we can find the net force, right? How do we find the net force?
Mass times acceleration.
Good. So F net equals MA. Which mass do I use this time?
10.
Just the 10, because I'm just looking for the net force on the 10 kilos.
The camera can't.
Is it done?
No, the camera can't see.
Oh, thank you, thank you.
10, 4.2.
Oh shoot, sorry about that, kids. That's there, thank you. MA, 10. Now, we need the acceleration. So we calculated the acceleration before, it's 4.3. And because that acceleration is the same for all the blocks, we can use it here.
This is literally facts.
So what's the answer?
43.
43.
The 100 will have.
My net force is 43. Is it positive or negative? It's positive. It's going that way, right?
And then the 100 would be negative.
So if you're mathy, you're going to say, I rest on the fact that all the forces added together will be my net force. So this is going to be friction plus tension, right? Because on this block we have friction and we have tension. So if I add them together, they have to equal this. So I want to find, what do I want to find again?
The FT.
We want to find FT. How do I solve for FT?
Oh, no, minus.
Adam, what do I got to do?
Plug in F net and F force of friction, and then you solve that.
Oh, well that's, yeah. I guess you could put the numbers in, but how would I solve for it formula-wise first?
We go F.
What do I do with
F
this?
net minus, yeah, F net minus force of friction.
Good. Very good. Excellent. Okay. What was my net force?
43.
43 newtons. We just calculated it. So 43 minus, now, is friction positive or negative?
Negative.
It's negative. I should have wrote negative. So we got to keep all these positives and negatives straight if you're going to be mathy. Negative 100. So you're minus negative 100. And that's going to equal 143. Yes?
Yes.
If you just said minus 100 and you ended up with negative 57, what clue would you have that that's the wrong answer?
It's smaller than.
Area.
It's smaller than
Good. If your answer is smaller than this, that's not going to work because we need this block to accelerate to the right. Yes. So this one makes better sense. So if you kind of keep track of the amounts a bit, you can kind of catch a mistake. Or you can check it with the other block as well. So that's our answer, 143. Now, if you're on a test and you're pressed for time and you're like, whew, go on to the next stuff, but put a little dot or something by the question. And if you have time at the end, you can come back to it and you can say, well, let's just check this and make sure. And then you look at the other block and you go, well, if the tension here is 143, the tension on this block should also be 143.
Correct.
So what would the net force on this block be? Be 250 minus 143, right?
Yeah.
Somewhere around 100, a little more, 107. And you say, okay, what's 107 times 25?
2,000, oh no, 25, I don't know.
20.
Oh no, sorry. What's 107 divided by 25? So we got the right acceleration.
Oh.
So we're good. I wouldn't expect you to necessarily do that in your head, but you can. Or you can write it out and do all the mathy stuff.
And you only have to solve for one side of the FT. Oh,
Yes.
yeah.
That's right.
Dang.
Bang. Boom.
Wait,
Okay.
money, is it still the same thing if the pulley was like vertical? You don't have to solve one FT at the same time? Yes.
So,
Yes.
I'm going to break some news to you.
Uh-oh.
There are, at the very least, 1,000 different situations that I can give to you involving force and tension. You will have multiple questions on your dynamics test of situations you have never seen before. Like you've seen them in the real world, but you've never done the calculations. That's on purpose, because I don't want you to think, oh, I can just memorize a formula and then I'll just put in the numbers and I'll get tension. Because that's not how it works in the real world, right? When you're engineering a bridge or a plane or an electric submarine, I really hope somebody here builds an electric submarine. I really think the world needs electric submarines. And it won't get
Isn't that just a nuclear submarine?
this is what I envision. You know all those boats, those ships in Vancouver that have the big crates and everything? I'm thinking like a really small port, and the submarine comes up and it rolls up on the beach, and then you like take the stuff out and you put the stuff you want to ship somewhere else, you just put that in there, and you just plop it in the ocean and just off it goes. It's just run on GPS with the lithium battery, just goes along. Under the water, always see it, it's fine.
Well,
So
wouldn't
if
that
someone
be a
would do
very-
that, that would be great.
Wouldn't that be a very small amount of cargo? So-
Yeah, but you can have 1,000 of them. You can have like
Oh,
a
it's like
train
little
all the way
Amazon
along.
delivery.
Instead of having this ship in port and like fill up with gas and empty all the stuff and all jet, blah, blah, it's just like, and then it just keeps going around, you know. And then you get your stuff like super fast. Not that we don't get our stuff super fast already. I signed up for Amazon Prime yesterday, the other day. I get the stuff before I even know I want it. I'm just kidding. It's almost that. I just click and I think, buy. In my hand. Yes, Yazzie.
What is our dynamics test?
Good question. Way to pull me back to earth. Your dynamics test is next week.
Oh,
Well, it's supposed to be. But I think I probably will push it to the week after, like the Monday or something. We are just now, finished Newton's laws. Oh no, we have to do Newton's third law. But we're pretty much finished Newton's third law. I can do Newton's third law in 5 minutes. I'll do a different video. And then we have to do, what is the other thing we have to do? Just some forces. So I have to teach you how to calculate friction and some other stuff. We're not doing momentum this year, you do it next year. So it'll probably be pretty short, actually. Should never say that. But yeah, expect it to be end of next week. I know it sucks. It's so quick. Okay, I'm gonna stop this. Moving on.